So now we'll go through the same exercise with hyperbolas that we've done with ellipses, parabolas, and circles. We want to find the center, vertices, and foci of the hyperbola given this equation, draw a sketch, and how would you enter it into your graphing calculator? Well, just as our ellipse was equal to 1, our hyperbola has to be equal to 1. So we're going to start by dividing everything by 36. So y squared over 9 minus x squared over 4 is equal to 1. So this is going to tell us that our hyperbola is going to open in the y direction. The reason for that is the first fraction, or the positive fraction, is the one that has the a term in it. And since y is the positive or the first one, that tells me I'm going to open in the y direction. This one, my center, is at 0, 0. I don't see any x minus quantity squared or y minus quantity squared. Since this is originally a squared and this is b squared, since a squared is equal to 9, that means a is equal to 3. And since b squared was equal to 4, that means b is equal to 2. So that's going to tell me how far my vertices are from the center. So I know my center is at 0, 0. And I've got to go 3 units in the y direction. So 1, 2, 3. And then down 1, 2, 3. So my vertices are going to be 0, 3, 0, negative 3. Next thing I want to do is I want to plot my horizontal piece, my b equals 2. From the center, I go 2 units over. And if I were to connect the dots, I would now have an ellipse. But since I've got a hyperbola, what I'm going to do is I'm going to create a box. And this box is a restricted area where the hyperbola can never go in. So I'm going to make a box that includes these 4 points. Now that I've got that box drawn, I can put in my asymptotes, which are going to be the guidelines for the hyperbola. The asymptotes go through the corner of the box and intersect at the center. So if I go through here, go through the center and through the corner of the box, those are my asymptotes, or my guidelines for the box. And if I look at these equations for the asymptote, it's going to be rise over run. So my rise here is 3 units up, my run is 2 units over. So my asymptotes would be in the format y equals plus or minus 3/2 x, just describing the lines of what those asymptotes are going to be. Now I want to know where my foci are. And for foci, I'm going to use the formula a squared plus b squared. So c squared is equal to 9 plus 4. C squared is 13. So c is equal to the square root of 13, which is about 3.6. So my foci are about 3.6 units up and 3.6 units down. That's where that plus or minus comes in, the 3.6 units up, 3.6 units down. So about right there would be my foci, and right there would be my foci, a little more than my 3 units. And the ordered pair for that would be 0, square root of 13 and 0, negative square root of 13. So now I can draw a quick sketch of my hyperbola. It's going to go along my asymptotes, never crossing them, and I get my 2 branches. The last piece that we're going to look at is how would I enter this into my graphing calculator? Well, if I have 4y squared minus 9x squared is equal to 36, we're talking about the calculator when we're in rectangular form. That means I need to get the y piece by itself. So here, 4y squared is equal to 36 plus 9x squared. Add 9x squared to both sides. Then we'll divide by 4. Y squared is 9 plus 9/4 x squared. And then finally, we take the square root. Y equals plus or minus the square root of 9 plus 9/4 x squared. That'll give me what my hyperbola would be inside of rectangular coordinates.